Frequency tables allow us to organize our data so that we can quickly answer questions about our data set. We're looking at a grouped cumulative relative frequency table, and the data in this table came from a survey of 100 male semi-professional soccer players. Now I called it a group table because we're dealing with an interval rather than individual data values. Each group covers a range of heights, so anybody that has a height between 59.95 inches and 61.95 inches would be grouped together in this first group. Counting the frequency is just counting how many of these soccer players have heights that fit into each of the different groups. So we can tell that we have 5 soccer players with heights that range between 59.95 and 61.95 inches. We don't know what their heights are just by looking at this table, but we know that they are within that range. Looking at our frequency table, we can answer various questions about our data set, even though we don't see each of the individual values from the data set. For example, we can find the percentage of heights that are less than 65.95 inches. Now to do that, I'm going to look at my table and find where 65.95 falls. 65.95 is right here, and we want everybody who is less than that height. So we're going to count all of the individuals that are above that row. And to do percentages, we can just read the value in our relative frequency column. So we could add all of the relative frequencies for those 3 rows, or we could use the cumulative relative frequency column, which has already added those for us. If we were to add the 0.05, the 0.03, and the 0.15, we would get 0.23. That's what cumulative relative frequency does for us. It adds up all the previous relative frequencies. So this is great. If we wanted to know the percentage of heights that are less than 65.95 inches, we just find 65.95 on our table, and we follow that all the way over to the cumulative relative frequency value. We take that decimal and convert it to a percentage because our question wants a percentage. So we would put 23%. We can also find the percentage of heights that fall between values. So looking at the next part of this question, 61.95 up to 65.95, we're looking at everything from 61.95 up to 65.95. So we're looking for all of the data value that lives here, and we want it as a percentage. Now in this case, I cannot just take the 0.23 because that would include the 5 individuals who are less than 61.95. We don't want that. We just want the 2 here, so we could take the 2 relative frequencies and add them together, and we would get 0.18. which we could convert to our percentage to say 18%. Let's do a few more. Let's find the percentage of heights that are from 67.95 to 71.95. So 67.95 to 71.95, that includes these 2 rows. We'll just add together the 0.17 and the 0.12. to get 0.29 or 29%. If we wanted to know the percentage of heights from 67.95 up to 73.95, we would just include these 3 rows. We'd add the 0.17, the 0.12, and the 0.7. We know 0.17 and 0.12 is 29, so we're just adding 7 to that. We get 36%. Our next question is asking us for all of the heights that are 65.95 and above. So 65.95 starts here. Anybody taller than that appears in these rows. Now I could add the 0.4, the 0.17, 0.12, 0.07, 0.01, but there's also a smaller shortcut that we can do. We know in our cumulative relative frequency column that as we're moving down, we're adding up to capture 100% of the data. We basically just want to leave off everything that's above this line. And we can see that there's 23% of the soccer players that are shorter than 65.95. So I could use the complement idea here to answer this question. There's two ways to do it. I can add the relative frequencies, 0.4, 0.17, 0.12, 0.07, 0.01, and I would get 77%. Or I can say 100% leaving out 0.23. That's the same thing. We get 77% either way we do it. So again, you can add your relative frequencies, or you can use the complement where you start by assuming you are including everybody and then just subtract the group that you want to leave out. If we wanted to just know the number of players in the sample who are between 61.95 and 71.95, instead of looking at my frequencies, the relative or cumulative frequencies, I'm going to read just the raw frequencies. So I'm adding these numbers up this time. So we have to read our questions carefully. Do they want a percentage, or do they just want a raw number of players? That's what they want this time. Adding these together, we get 87. 87 soccer players are between 61.95 and 71.95. These heights, we already talked about it, they're measurements, so we know that they're numerical, specifically quantitative continuous because they're measurements. The last part asks us to describe how you could gather this type of data so that the data are characteristic of all male semi-professional soccer players. This is a question to make sure that we are being mindful about our different sampling techniques. So we could always say, do a simple random sample, draw names from a hat. We could use a systematic list. We could describe any one of those types of techniques where we're taking the population, which is all male semi-professional soccer players, and we are using a sampling technique to take 100 of those players out. So maybe we list them alphabetically and we take every fifth person on the list until we have 100.